Part 2 of 3.2, linear functions. Started these yesterday. Told you today we'd finish them, so let's knock it out real quick. So there's multiple ways to represent a function. You can use words to represent a function. So here's an example. It says an output is 3 more than the input. An output is 3 more than the input. So in equation form, that would look like y equals x plus 3. Y values are my outputs, correct?
Yeah.
So my outputs equal my inputs plus 3, because plus 3 would be 3 more than my input. Does that make sense? So y equals x plus 3. You guys have seen an input-output table before, right? Table of values. If I input -1, -1 plus 3 gives me 2. If I input 0, 0 plus 3 gives me 3. If I input 1, 1 plus 3 gives me 4. And input 2, 2 plus 3 gives me 5. We okay with that?
Yeah.
We're okay with putting in a number, getting out a y value. Okay? And then we saw mapping diagrams last week, I believe. We all understand how my mapping diagram works.
Yeah.
The x values map to the y values. So -1 maps to 2, 0 maps to 3, 1 to 4, 2 and 5, so on and so forth. And then lastly, I can represent a function by a graph. I can just graph all my ordered pairs. So -1, 2, 0, 3, 1, 4, 2, 5. And this would keep going because I could keep inputting numbers, correct? And keep getting outputs, so I could keep getting ordered pairs. That's why there's arrows on our graph. It keeps going on forever and ever and ever in either direction. Are there any questions about any of the representations of functions? We all understand each representation. This means yes. This means no. Do we understand? Okay. So let's talk about graphs of linear functions. A solution of a linear equation in 2 variables is an ordered pair, x, y, that makes the equation true. So on our previous slide, all these ordered pairs, -1, 2, 0, 3, 1, 4, 2, 5, those are solutions to my function here. If I plug them in, so plug 2 in for y, -1 in for x, what's -1 plus 3? What did we say? -1 plus 3 gave me? 2. If I have 2 over here for y, does 2 equal 2? Yes. It gives me a true statement, right? So each ordered pair that I plug in and I get a true statement is a solution to that function. Does that make sense? So that's what that first sentence is saying. The graph of a linear equation in 2 variables is a set of points, x, y, in a coordinate plane that represents all solutions of the equation. So every point on this line, every ordered pair, is a solution to that equation. So how many solutions do I have here?
Infinity.
An infinite number of solutions, right? Because this keeps going on forever and ever, up and to the right, and down and to the left. The graph, the line is just a representation of all those solutions. That makes sense? That does not make sense? Oh, it does make sense. Okay. Sometimes the points are distinct, and other times the points are connected. We've kind of talked about that a little bit before with discrete and continuous. Discrete, my points were not connected, were they? It was just very specific points, right? For continuous, all my points were connected with a curve or with a line, right?
Yeah.
We'll talk about that a little more here in a little bit. Are there any questions about any of the information on this slide? Okay, can I move on? Here's discrete and continuous. So a lot of times we'll talk about the domains being discrete and continuous. A discrete domain is a set of input values that consists of only certain numbers in an interval. AKA the points are not connected, right? So here's an example, would be the integers from 1 to 5. Integers are only whole numbers and the negative whole numbers. Okay? So if it's the integers from 1 to 5, does that include like 1.1?
Yeah.
It does?
No.
No, it does not. 1.1 is not an integer. 3.75 would include that. No, it's just the integers from 1 to 5. So just 1, just 2, just 3, just 4, just 5. It only contains a certain numbers in the interval. Okay? So the points are not connected. A continuous domain is a set of input values that consists of all numbers in an interval. So all real numbers in that interval. So an example would be all numbers from 1 to 5. Now my points are connected with that line. Is 1.1 included? Yeah. Is 3.75 included? Yeah. So every single real number between 1 and 5 is included on this bottom one. Does everyone understand the difference between discrete and continuous? We're okay with that? Okay. Here's an example here. The linear function y equals 15.95x represents the cost y in dollars of X tickets for a museum. Each customer can buy a maximum of 4 tickets. So there's all the information they're giving me. Letter A says find the domain of the function. Is the domain discrete or continuous? And explain. So let's first find the domain of my function. Domain is my set of X values. What part of our scenario is being represented by X? What does X represent here? The number of tickets being bought by a customer, right? And Y is the cost in dollars. So I'm looking for my domain, the amount of tickets a customer can buy. What does it tell me about how much a customer can buy? They can only buy a maximum of 4 tickets, right? So what would be my domain here? Just 4? 1, 2, 3, 4. Does everyone agree with that? Let me ask you this. Can a customer buy 0 tickets? Yeah, they don't have to buy a ticket, do they? Can they buy negative tickets? No. So 1, 0, 1. Are we including numbers between 0 and 1? Why not? Very good. You can't buy half a ticket. I can't buy a third of a ticket. I've got to buy whole tickets, right? So my domain is just 0, 1, 2, 3, and 4. It puts a limit on the amount of tickets I can buy, right? So are these the only numbers in my domain? Yes, just these 5 specific numbers, right? Okay, so there's my domain. Is this domain discrete or continuous, and why? Discrete, because I can't, like we said, I can't buy half a ticket, right? So I can't include numbers between these whole numbers. Okay? Does that make sense for letter A? Any confusion on what we just covered on letter A? Letter B says graph the function using its domain. Any ideas how we're going to do that? And it's not talking about on a number line. It wants it on an XY coordinate plane. How am I going to graph this using my domain? My domain is my set of X values. In order to graph, I need X values and Y values, right? So how am I going to get my Y values that correspond with these X values?
Multiply 1 times 15.
Very good. I've got to plug each X value into my given function, right? That way I can get the total cost for each set of number of tickets bought. So here's our domain. 0, 1, 2, 3, 4. Here's our function. So what I'm going to do is I'm going to create an input-output table of values, okay? I've already got my X values, right? And like we said, I've just got to plug in to my function to get my corresponding Y values. So let's plug 0 in first for X. So that'd become 15.95 times 0. What does that give me? 0, right? If I buy 0 tickets, I spend $0. Right? So my first ordered pair is at the origin. And I'm going to make my y-axis go up by tens. Everyone okay with that? Okay, let's plug 1 in. 15.95 times 1 would give me what? 15.95. So I'm going to go right 1, up 15.95. Should be somewhere in there. Someone have a calculator? They can type the rest of these in for me. 15.95 times 2. 31.9. So I'm going to go right 2, up 31.9. Somewhere in there. Plug in 3. 15.95 times 3.
47.85.
47.85. So right 3. Up 47.85. And lastly, plug 4 in. 15.95 times 4.
63.8.
63.8. So right 4. Up 63.8. There any questions how I graphed my function using my domain? We all understand that. We got x values, so we can plug them into our function and get our corresponding y values and just plot those ordered pairs. We're good with that. Do I need to connect these points? Why not? Why? You said both, so yes or no? No. Yeah, very good. It's a discrete function, right? We had a discrete domain. So I can't include these x values between my numbers because I can only buy whole tickets, right? Do I have any negative numbers in my domain? No, because I can't buy negative tickets either, can I? So this is just the graph just like this. Just these 5 ordered pairs. Questions on this example? Can I move on? Okay. Another example. A cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. Says, does this situation represent a linear function? And explain. Can someone say yes or no and tell me why? Will this be linear or nonlinear? How do we know if something's linear or not based on, well, we don't have a graph, so we can't look at the graph. Yep.
The rate of change,
What about it?
if it's constant or
If we have a constant rate of change, it is
linear.
linear. If it does not have a constant rate of change, it is non-linear. So let's talk about the rate of change here. Okay? We don't have X and Y, but we have B and C, right? What happens as I eat 1 bar? I eat 130 calories. What happens if I eat 2 bars?
260.
I eat 260. So is it increasing by the same thing each time or decreasing? Yeah. So is that a constant rate of change? Yeah. So I'd say this situation does represent a linear function because it has a constant rate of change. Does that make sense? Any confusion on that? Okay, so letter A is done. We've answered it. Letter B, find the domain of the function. Is the domain discrete or continuous? And explain. What would my domain be here?
The amount of bars in it.
The amount of bars that I eat, my x values, right? Or in this case, our b values. So can I eat negative bars? No. Can I eat 0 bars? Yeah. I can eat 1 bar, obviously. Can I eat half a bar?
Yes.
Yeah. Can I eat 3 3/4 of bars?
Yes.
Yeah. So I'm including all those numbers between my integers, right? So how would I represent my domain here? It is going to be continuous, but how would I write my domain? Because it wants me to find the domain first. All real numbers? Well, we said we couldn't eat negative bars, right?
It'd be greater than 0 or equal, greater than or equal to 0.
Greater than or equal to 0, right? So I'm going to say B is greater than or equal to 0. And that's the only inequality I need, right? Because do they put a cap on how many bars I can eat? No. You'll probably get sick if you eat too much. But you could eat 2 this day, and then the very next day eat 2 more, right? Just keep doing that every day. There's no limit to how many bars you could eat, are there? So I could have, my domain consists of all numbers that are greater than or equal to 0. Okay? Does that make sense for our domain? So what did we say about our domain? Is it discrete or continuous, and why?
Continuous because there's not a limit after you go 0.
And I'm not just including certain like integers or anything, am I? I can eat half a bar. I can eat 3/4 of a bar, right? So it'd be continuous because my points are connected because I can include all those numbers between my integers. Okay? Questions on B? Okay. Letter C, graph the function using its domain. So we're going to kind of make another chart by our graph. Here's our domain. We're not going to have an XY column. We'll have a B and a C column. Starting at 0, how many calories is each bar worth? 130 calories, right? So if I eat 0 bars, how many calories have I consumed? 0 from the bars. I probably ate something else that day, right? But I haven't consumed any calories from the bars. If I eat 1 bar, how many calories have I consumed from the bars? 130. If I eat 2 bars, how many calories? 260. 3 bars, 390. 4 bars, 520. So on and so forth, right? So let's go ahead and graph these. Is everyone okay if I just make my graph go up by 130 each time? My y-axis? So 130, 260, 390, 520, and 680. Or 50, my bad. Okay, so we said 0, 0. It's my origin. 1 bar is 130 calories, so I'm going to go right 1 up 130. 2 bars is 260 calories, so right 2 up 260. 3, 390. 4, 520, so on and so forth. We said there's no limit, right? So I'm going to extend my line past these points. And what am I going to draw on the end of my line? An arrow to let people know and myself know that that's going to go on forever and ever and ever. Okay? Just like that. Do I need an arrow on this end of the line?
No.
Why?
You can't eat negative.
Very good. It stops at 0, 0, right? So I cannot extend it any further. It's not going to continue in that direction. It's just going to go up and to the right. Okay? Does that make sense for this example? On how we graphed using the domain. Good? Once again, we had to draw a line through our points because we can include numbers between 0 and 1, between 1 and 2. Every point on this line is a solution to my function. Okay? We good? Can I move on? Here's your assignment. Page 120 through 121, numbers 27 through 36 all. It's 10 problems. We do It's 10. You got to include 27 as well when you're counting the numbers. This will be due Thursday. Oh, God. That'd be the 27th on Canvas. Make sure you get this written down. Make sure you get the correct heading on your paper. Name, date, period, assignment in the upper right-hand corner. Do we have any questions about the notes before I end my recording?
No.
All right.